welcome you to this special edition of our English language session. Today, we're going to see a very simple thing in mathematics. Assalamu alaikum, my students in the studio and viewers at home. Welcome back to yet another edition of the NTA Busau Learning by Television, a program organized by Muslim Student Society of Nigeria in conjunction with the NTA Busau. This is your regular uncle, your regular guardian, your regular teacher, Anas Hamisulawal, with the mathematics class. Welcome. Can you put hands together for yourselves? Yes. My students, and especially you viewers at home, if you are just joining us, this is the mathematics class. And if you are not ready, I will give you some seconds to get a paper, a piece of paper, and a pen to get ready for this very class. Yes. In our previous class, we were able to see some aspects of indices. We have seen how to write a number in its index form. Is that? Yes. Yes. And we were able to even go further to start seeing those laws of indices, which I told you are what? How many laws of indices we have? 6 laws of indices. And of those 6 laws of indices, we were able to take 2 out of the 6 laws of indices. Number 1, which law? The multiplication law. Number 2, the what? The division law. We have seen that if we have powers, complex cases of powers, when it involves multiplication, what we do is we do what? We add the powers. Is that? Under which condition? If the bases are what? If the bases are, I cannot hear you. If the bases are what? Are the same. And in the case of division, what do? We subtract the powers. Is that? We subtract what? The powers. What is the condition? The bases must be what? The same. That's very good. And I believed I left with you an assignment to do. Don't worry. Before I go, I will take that assignment and I will mark it for you. Are we together? Yes. Together? Yes. Good. Our today's class will be a continuation of those laws. We have seen 2 and we are going to proceed with the remaining 4. And the third one, the third law of indices is what? The powers law. Can you say it again? The powers law. This is, in other words, what? The case of what? Multiple powers. Or let me say 2 powers. And that, by definition, we can say if we have a number a raised to the power m, and this number again is raised to a power n. How many powers? 2. If you have this kind of situation, what will be the result? The result is a, this number, raised to power m multiplied by n. So what this law is saying, if you have 2 powers, mn, all you need to do is what? Just multiply the what? The powers. By way of example, if we have 3 raised to power 3, power 4, what will be this result? This is the same thing as saying 3 raised to power what? 3 times 4. And this is what? 3 raised to power 3 times 4? 12. Do you want us to put it in the extended form? Let's see. This is 3 raised to power what? 3. 3 in how many places? 3 in what? 3 places. And this 3 in how many places again? This 3 in how many places? 4 places. So I will have a combination of 3, 3, 3 in how many places? 4 places. So I have a set 1 here, multiplied by 3, multiplied by 3, multiplied by 3. The second 3. Is that? 3, 3, 3. The third one. 3, 3, 3. The fourth one. Are we together? Count, let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is that not the same? Instead of writing this lengthy numbers, in this case, what you need to do is just what? Take the powers, multiply the powers. You have 3 here, you have 4 here. When you multiply them, you get what? 3 raised to power 12. Are we together? Yes. So that is the powers law. So what the powers law is saying is that for powers, we multiply the index. For powers, what we do is what? We multiply the index. What are the index? The powers. Go? I told you in the previous class, power means what? Index. Is that? That is why we say the two powers and index are what? Are used interchangeably in mathematics. That is law number 3 for you. Simple? Is it simple? Yes, it is, because it's just multiplying the power. Now, law number 4 is what? Law number 4 is the fractional indices. Fractional what? Indices. As the name implies, fractional. It involves what? Fraction. It involves what? Fraction. So this time around, we have been using, in the previous laws, we have been using index that are what? That are not fractional. Because this is not a fraction, is that? Yes. This is not a fraction. What happens if it is a fraction? What happens if it is what? If it is a fraction. So this law is saying, when you have a raised to power, this time around 1 all over m. The base raised to a power what? The power which is what? Which is a fraction. This one is not a fraction, but this one it is what? A fraction. So when you have this kind of situation, what will be the result? And this law, the fractional indices law, says what? This is the same thing as mth root of what? A. This is not 9, it is A. A raised to power 1 all over m is the same thing as what? Mth root of A. Now for the purpose of this law, let's make some little definitions. Previously, I believe you know what is called square root. You know cube root. You know fourth root. And this is the sign. Square root is what? By way of definition, square root is what? 2, let's define this. 2 raised to power 1 all over 2. 2 raised to power 1 all over 2. This is what? 2 raised to power 1 all over 2. It's the same thing as what? It's the same thing as square root. Square root of what? 2. So this 1 all over 2 is what gives you what? Square root. Now when it is raised to power 1 all over 3, for example, 2 raised to power 1 all over 3. This will be what? You will be what? 3 will be here, and it will be cube root of what? 2. So this denominator, it is assumed that this 2 is here, but because if it is square, whenever you hear square, it is what? 2. Is that? When it is cube, it is what? 3. When it is fourth, it is what? 4. So by this, because this involves root. But let's go again further to define what is a root. What is a what? Root of a number. What is a root of a number? Because we are talking root. This is square root. This is cube root. This is fourth root. What is a cube of a number? A root of a number. You can write this one, and you out there can write also. A root of a number. A root of a number. Say x. A root of a number x is another number. A root of a number x is another number which when multiplied by itself a given number of times, the result is x. That is the definition of a root of a number. For example, if I ask you to give me square root of a number 4, square root of a number 4, you will be thinking of another number, a different number, that when it multiplies itself a number of times, it will give me this number 4. Think of a number that when that number multiplies itself a number of times, it can be 2, it can be 3 times, it can be 4 times. When it multiplies itself, it will give you number 4. Which number is this in the whole of the universe? 2. It is only 2 that will multiply itself how many times? It will multiply itself 2 times. That is 2 times what? 2. It is 2 times 2 that will give you 4. There is no other number in this universe that if you multiply it by itself, that number, it will give you 4. 9. What is the square root of a number 9? 3. The square root of a number 9 is 3. How many times 3 will multiply itself? 3 times 3. That is 2 times that, and it will give you that. Are we together? Yes. Now, cube root. When you talk of cube root, it means a number will multiply itself in how many times? 3 times. Is that? Square root, it is 2, it multiplies 2 times. So like for example, if I give you a number 8, in the case of square root, you don't need to mention it is square root 2. So automatically it is. The root starts with what? 2. But when it is cube root, you must designate that yes, this number is talking about, or this root is talking about what? The third root, which is the cube root. So you must write 3 here to tell you it is what? Cube root. So what is the cube root of a number 8? Which number can you will multiply itself 3 times and the result will be 8? Which number is that? 2. 2 will multiply itself 3 times to give us 8, because 2 multiplied by 2 multiplied by what? 2. 2 times 2, 4 times 2, 8. So the cube root of a number 8 is what? Is 2. Are we together? Yes, we are. Now, if we have a case, coming back to this, this is a case of what? A numerator and denominator. In this case, denominator, that is the upper number in the power, is what? 1. So tell me what happens if this number is not 1. For example, if we have a raised to power m all over n, what will be the case? The case will be what? Denominator takes the what? Root. It's going to be what? Nth root of a. Where do you go with this m? We take it to the power of what? M. So you see, this law, the fractional law, split into what? 2. We have a situation where denominator is 1. And we have a situation if denominator is not what? It is not 1. Here, if we have 1, this is the result. And here, if we have a number other than 1, the result will be 6. Are we together?
Yes.
Let's see an example here. Simplify (81) raised to power 1 all over 4. 81 raised to power 1 all over 4. This is a clear case of what? A fractional indices. Is that? The power is what? Is a fraction, which is 1 all over 4. In that case, from our law number 4, which says if we have a raised to power 1 all over m, the result will be what? M root of a. So what will be this result? By this, from law number 4, is going to be what? Fourth root of what? 81. Now we'll be thinking of a number that when we multiply that number how many times? When that number multiplies itself how many times? 4 times. It will give us 81. Think of that number. Which number is that?
9.
Somebody is saying 9 and somebody is saying 3. Which one do I go with? Viewers at home, I know they will tell you I should take the first one. Which says what? 3. Because if we multiply 3, how many times? 4 times, go? 3 times 3 times 3 times 3. If this number gives us 81, so 3 is the fourth root of 81. What is 3 times 3? 9 times 3? 27 times 3? 81. This is 81. So the fourth root of 81 is what? 3. Therefore, 81 raised to power 1 all over 4 is the same thing as what? 3. You see, the whole of this became what? 3. Is that not simplification? Something that looks complex, you simplify it and it became what? The result became 3. I told you, indices is very simple. And generally, mathematics is very simple. Because as the name implies, simplify. Something looking complex, you what? You simplify it to the barest or to the simplest form. Is there any questions regarding this? No. No. Now what happens? What happens if we say simplify 81 raised to power 2 all over 4. 81 raised to power 2 all over 4. I know quickly you will tell me it is what? Tell me. It is what? Fourth root. Say it louder. Fourth root of 81 all raised to power what? 2. And we already know what? the fourth root of 81. What is the fourth root of 81? 3. So it's going to be 3 raised to power what? 2. And 3 raised to power 2 is the same thing as what? 3 times 3, which is what? 9. Simple. Class, are we together?
Yes.
Yes, we are. Now the fifth law. That is the law we call the Bagas law. Did you hear me? The Bagas law. And that is the law that says, that is where the law we give the zero index. The zero index law. The zero what? Index law. When we say zero index, we need to say this time around the power is what? What is index? Power, oh? So the power is what? 0. So this law is saying if anything A raised to power 0 is not what? Any number, when you raise it to the power of 0, the result is what? 1. So tell me, 1,000 raised to power 0. 100 raised to power 0. 1 million raised to power 0. Okay, you keep your answers. I know you will tell me 550,000 raised to power 0 is equally 1. Is that correct? Yes. Anything raised to power 0, the result is 1. Did you see why we call it the Bagas law? It is the most simplest of all the laws, because you always like anything that is very simple. Okay, so anything in indices, anything raised to power 0 is what? 1. And finally, the sixth law of indices is the what? The negative power or the negative index law. The negative what? Index law. And that is the law, as the name implies. If we have been dealing with positive powers, oh? M, N, all positive. Now what happens if the power, that is the index, if the index is a negative number? That the law says when you have A raised to power minus M, this is negative index. A raised to power minus M, the result of this kind of case is what? 1 all over A raised to power M. A raised to power minus M is the same thing as what? 1 all over A raised to power M. By way of example, if you have 3 raised to power minus 2, what will be the result? This result will be what? 1 all over 3 raised to power 2. And this is 1 all over what? 3 raised to power 2 is 9. And this is the result of 3 raised to power minus 2. So by this, in the case of a negative index, when you have a negative index, the number raised, the number you raise to a negative power is equal to what? The reciprocal of the positive power. Look at it. This is a negative power. And this is reciprocal, is that? Because I told you, we've seen reciprocal. A. What is the reciprocal of A? 1 all over A. Now, you have A raised to power minus M. So the result is, the power is what? Negative. Now, you take the reciprocal of the number, but you now change the what? The power or the index to become a positive index. Class, are we together?
Yes.
Viewers right there at home, I believe we are equally together. And these are the laws of indices. Is that understood?
Yes.
Are we together?
Yes.
Can you put hands together for yourself?
Yes.
We have been together from the beginning of this laws, and here we are to the end of this laws. Is there any question? I believe there is more question. Yes. The next thing we are going to see in our next class is let's see the cases of complex cases of indices. How do we do the theater? You know, doctors, when they do theater, they open the stomach, they see the intestine, the whatever you ate in that very day, they will see it in your stomach. So we're going to bring cases that are complex in nature. And we use these laws. Like I told you earlier, indices or laws of indices makes it easy for one to solve complex cases involving what? Powers. So next class, we're going to see that. Until then, you have a takeaway. Right. And I will give you just one takeaway. When you go home, solve. We meet next class, you submit. And that is just it. 3x raised to power 2 multiplied by 4x raised to power 6 divided by 3x raised to power 2. This is your takeaway. Until then, Assalamu alaikum wa rahmatullahi wa barakatuh.